Hello everyone, welcome back to another fresh and innovative video on my channel. What we have today with us? We are going to learn pulse width modulation and then we will look into its applications in electronics. So come on guys, let's start without wasting any time. So first we will talk about what is pulse width modulation and then we'll proceed ahead. Pulse width modulation, primarily known as PWM, is very efficient way to produce analog outputs using digital pins. Let me explain you ahead that how it works. So basically, as we know that digital signals are square waves, right? That are switched on and off between maxima and minima, and hence we can't generate analog signals using them, right? But what we can do is we can modulate or control the digital square wave from on and off in such a manner that its duty cycle is controlled by us. That is, if it is switching on and off in, for example, in 1 millisecond to maximum, then we will only switch it on for say half a millisecond and block the other half. So basically, we end up getting only half time period as on and the remaining time period as off. Sounds strange, right? But when this is done at a rate of 1 megahertz, that is the frequency rate at which our Arduino's digital pins are operating, then our eyes assume that we are seeing analog output, but actually it is just an LED blinking on and off, nothing else. Got it? Just try to understand this diagram. Start analyzing the diagram from the bottom side. Don't look at those numbers 255 and all, just see that graph. So when we have 100% of the duty cycle, then complete 5 volt is showing up for full time period, right? But as we decrease the duty cycle to say 127, then the intensity is reduced to half, but still for that half time period, complete 5 volt is working. But as I already told that when this is done at a very high frequency for a period of time, then it seems like we are getting half of the voltage. It's very complicated thing to understand, but when you see this thing happening in real life, then you all will understand it more clearly. Don't worry, I'll be showing its demonstration ahead. So now we will talk about the technicalities of PWM. Our Arduino Uno features 6 8-bit DAC channels that are controlled by 3 timers. Secondly, to call these DAC channels, we just only need to follow this command, analog write, and then pass these arguments with it. We are done, right? Next, we have our duty cycle that ranges from 0 to 255. Since these are 8-bit channels, so 2 to the power 8 is 256. So here is how the 255 arises earlier. So most of the students will end up here. But there is an interesting thing that you can achieve. That is, you can enable PWM on any digital pin you want. The method is known as bit banking PWM and it's quite easy to implement. I'll show you that how you can implement that in the later part of this video. Here are some of the uses of PWM. So today we will be looking at the very first application, that is how we can fade an LED. Okay. So for that we need to create this very basic circuit that we created in our digital pins video. If you guys have not watched the video yet, I suggest you all to watch that first. Okay, so coming back to our this PWM applications, only changes here is that this time we need to connect the positive terminal to any one of the PWM pin. So in my case, I connected it to pin number 6. You guys can choose any of the 6 PWM pins present on the board. Coming to the coding section, it's really simple. First, we need to initialize LED pin as a global variable. Then in the setup function, we will declare pin mode LED as output. Now in the loop function, we will create a variable first that we will change its value from 0 to 255 so that we can observe that fading effect. Okay. In the for loop, we will declare the range and then write the PWM command that we learned earlier, that is analog write and then the LED and state inside the arguments. Then to observe this effect, we will also declare a delay in the same for loop. This is all for the increasing brightness. Now we will do the reverse of this to dim the LED. For that we need another variable that will range from 255 to 0 and will dim the LED. So here is the code for the same. Now after selecting the right comport and board in the tools menu, as we always check, we will upload our code. So here is what you get as output after this. So we are done with the most commonly used PWM. Now, as I said, I'll teach you that how to enable PWM on any digital pin. So for that, just write this code in your Arduino IDEs and then upload it, and you will see that you can see a dimmer LED on the output. But basically, what this program is doing is just again creating a pseudo effect in your mind that the digital pin, in my case, it's pin number 8, is showing only 10% of the output, hence resulting in a dim LED. So here is the comparison of the two LED brightness after implementing bit banging PWM on pin number 8. So that is all guys for this video. I hope you all enjoyed this video. If yes, then please like, subscribe and comment all your queries, and I'll see you all in the next video.